M2U00327 model. Today I want to present to you the result section for my investigation, for my research, plastic injection using genetic algorithms and Petri nets. First, I want to remember what is the problem, what was the hypothesis that we have at the beginning. This is the process using pellets, small balls of plastic. These heated and melted and then pushed by a screw in order to form plastic pieces that we know in our life. That is the way in which it works. But in order to produce that plastic parts, we have to use a mold of injection that is using this last part. But time to time, that kind of mold is damaged. So we have to fabricate this product that is composed, as you can see, by a lot of different pieces. So our hypothesis was how to use a modeling tool like a Petri net. This is just a small representation of a very simple situation. How to using Petri nets as a modeling tool, mass plus sorry, the use of a genetic algorithm in order to use as a optimization tool, how to produce for this case a schedule, understanding the schedule as a assignment of tasks over the time using some resources. So the hypothesis was how good would be that marriage, that combined use of the tools to produce the scheduling of the mold. We have to remember that in this kind of problems are present basically these four components that make the problem more complex. Assembly operations, precedence between jobs, and the appearance of ghost task. Okay, just to understand. I want to show you how it looks like a very small model of the Petri net that model these kind of problems. This is just in the below of the screen is the places that represent the machines in the plant, and the other is the logic in order to fabricate the mold. But this is just a very small model. Okay. In order to obtain so we want to see what is the icon to display the
presentación con diapositivas arriba. Desde la diapositiva. Second.
Yeah. In order to obtain, to validate the hypothesis, partial result was was obtained, that was the proposed mathematical model to solve in an exact way the problem. This is the result of our research. Is to minimize the total weight doubliness, and the constraint that we use were the following that relate with the constraints that explicitly we have to consider. For example, these establish minimum values, minimum lower bounds for the start time of the operations, and so on. How the results obtained, exact results were obtained, use solver provided by the National Science Foundation and several universities in the United States, because they provide very robust grid for parallel computation. The results looks like this. For our method, we report the minimum, median, and maximum, and measure of the deviation with respect with the best value obtained by any of the methods. The solution provided by the mathematical model, or the best incumbent solution when the instance couldn't be solved as an exact mode, and the dispatch rule is compared with the A-star algorithm that was published in the by Montoya and Mejia in 2008. In all, the results shows that our proposed method is very good. About the 65% of the instances were solved with better solution than the other methods. And if we see that information using the deviation, we found that 80% of the instance were solved with the best, with zero deviation, and the 36% of the instances were solved with less than 10% of the deviation with respect to the best method. However, if we analyze that results by categories, which we can see that that the more bigger, the more large is the instance, the less is the effectiveness, the accuracy of the method. So it could be referent to future research. That behavior is explained because although the chromosome use looks naive, it performs well for smaller and medium instances, and the behavior of the decrease of the accuracy and the performance of the method is because the premature convergence of the chromosome. So it is the origin to future work. We right now are working in strategies for rescheduling. Another topic is dynamic programming algorithm over this reachability graph. And finally, it is necessary to work in the improvement of the problem of the redundant synonymous representation. Any question?
I have a question. Have you proved maybe the multi-population genetic algorithm? Maybe.
No, this is just the idea was not to use complex configuration in the genetic algorithm. Just to prove if the chromosome representation was good enough. But your solution, your idea is good in order to avoid that problem.
Yeah.
For the next.